So let's find the sum of the series. Let's see. 1 over 1 times 2 plus 1 over 2 times 2 squared. Oh wait, there should be a minus here. Minus 1 over 3 times 2 cubed minus 1 over 4 times 2 to the 4th plus dot dot dot. Okay. So previously, what could we find the sum of? We could find the sum of a geometric series. The formula was a over 1 minus r. Or there was one on our test with the telescoping series. We could find a sum in that case if it converged. Those were the only two. If you look, this is not telescoping. Things aren't canceling out with each other. And it's not geometric. If you take the ratio of the second over the first and then the third over the second, you're not going to get the same number. So this is not either one of the problems we could do before with sum. This is a little bit different, okay? It would help if we had a formula for this series to begin with. So let's try to come up with a formula for this in general. N equals, let's say, 1 to infinity. And tell me something, you got to write down the formula in general. Tell me something you notice about these terms. They alternate. So I need a negative 1 to a power. Negative 1. The first term is positive, and I start off at 1 here. So what should my exponent be? N or n minus 1? N minus 1. Okay, so we've taken care of the alternating part. What else do you notice with these terms? What are the numerators of my fractions? Just 1. Okay, so let's put that in there. 1 over. Now focus on the denominators. N, okay, n times what? 2 to the n. Okay, we all okay with coming up with that formula? You just dissect each piece. I took the alternating sign. We did that first. Look at the numerators, look at the denominators, find the patterns. Okay, so this is a series. There's no x here. It's not a power series. It's not Maclaurin or Taylor series right now. Okay, so what I'm going to do is I'm going to rewrite this a little bit. What I'm going to do is I'm going to highlight the part I'm going to rewrite here. This 1 over 2 to the n, I'm going to rewrite that as the sum n equals 1 to infinity, negative 1 to the n minus 1. This is 1/2 to the n over n. Okay? Because 1 to the n is just 1. This is still 1 over 2 to the n divided by n.
How do you know if it starts at 1 or if it starts at 0?
It was a choice I made.
Okay.
I am going to talk a little bit about relabeling, re-indexing sums if I have time today. Not tomorrow. Okay. So we're supposed to use Maclaurin series to help us here. But Maclaurin series, their power series, so I should have an x. So what I'm going to do, that number 1/2, I'm going to think about that as being an x. And I'm going to ask myself, what series is it if I replace that 1/2 with an x? So take, this is not equal to what we have. I'm making a change. I'm replacing this by x to the n, and 1/2 by an x. Okay. And you should look at our list of Maclaurin series and tell me, does this series appear in that list? It appears as the ln one, the next to last one. This was ln of 1 plus x. So if I compare this with mine, the one I had in the problem, compare this with what I have up here, the only difference is x has been replaced by 1/2. And remember your radius of convergence for this one, if you look back when we wrote down the formula, it was 1. So the interval of convergence is from -1 to 1. 1/2 is inside of that interval of convergence, so I can plug in 1/2 here. Okay, so let's plug in 1/2 into this, and we get exactly the series we're trying to find the sum of, 1/2. But when I plug in 1/2 on the other side, I'm going to get ln of 1 plus 1/2, or ln of 3/2. So you secretly, not so secret, but you found the sum of the series. It's ln of 3/2. Just by using your Maclaurin series and plugging in a value for x, you can now find the sum of a series. Okay. So again, this is kind of opening up for us a new possibilities. We couldn't find the sum of this series before, but now we can.
Can you tell me why you were able to plug in 1/2?
1/2? Yes. Okay, so we were able to plug in 1/2 because we're basing everything off of this series right here. And what was this series radius of convergence? The radius of convergence was 1. And this is a Maclaurin series, so it's centered at 0, which means our interval of convergence, it's -1 to 1. It could include the endpoints, I'm not sure. So maybe I won't. This isn't really the interval of convergence. Maybe I won't say that. But for sure, it converges in between -1 and 1. And I plugged in 1/2, which is in between -1 and 1. So because 1/2 is in this interval, we're good to go. So maybe what I'll say is we were able to do this because 1/2 is between these values. Some of our power series, or our Maclaurin series, had the radius of convergence being infinity, so you can plug in any number you want then in place of x.
And that'll give you the sum.
And that'll give you the sum. It'll be in terms of whatever function you were finding. The Maclaurin series is 4. Yeah. Okay, so one thing it can do for us now is it can find sums for us. Okay, of series. The second thing I want to mention is that it can calculate integrals for us, which I've touched on before, but I'm going to touch on it again now. So let's say I want you to evaluate the integral e to the negative x squared dx as an infinite series. So for this, it's telling me if I'm going to compute this integral, I need to write this function down, e to the negative x squared. I need to write down its function as a power series, or as a series. So if you look at our list of Maclaurin series, e to the negative x squared is not going to be on that list. But there was a function that was similar to this one on that list. Which function was on that list? That's like this. E to the x. So let's write down that one, and hopefully I can get my Maclaurin series from that one. So let's write down e to the x. It was the sum from n equals 0 to infinity x to the n over n factorial. So what's the difference between e to the x and e to the minus x squared? The exponents are a little different, right? But the base is still the same. So all we've got to do to get my Maclaurin series is I need to take this x here and replace it with a minus x squared in the formula, okay? So again, you can kind of bypass, you don't have to make the table this time. If I want the Maclaurin series for e to the negative x squared, I'm just going to replace x by negative x squared. Just drop in a negative x squared in place of x. And then I am going to need to integrate, so I'm going to separate out the minus sign. I'm going to write this as negative 1 to the n, x to the 2n over n factorial. Okay? And now we have our Maclaurin series for e to the negative x squared. And I wanted to integrate this, so I just need to integrate this series here. The integral of e to the negative x squared dx. I need to integrate this series here. Now here's the part where do whatever works for you. If you need to write out the terms, then write them out. But you could also just integrate this. Think about your integrating variable is x. You have a dx there. So the only thing you're really integrating here is this x to the 2/9 or x to the 2n. So I'm getting c. Every time you integrate, you get a c, an indefinite integral. The sum from n equals 0 to infinity. The rest just stays the same, n factorial. And then do the reverse power rule where you add 1 to the power, x to the 2n plus 1 over 2n plus 1. Okay. In this case, I don't know what the integral of e to the negative x squared is, so I can't solve for c. So this would be your answer right here. Okay.
Can you explain how you get x to n plus 1?
I'm doing, think about n as being a fixed number. Okay? So 2 times n is a fixed number. And when you integrate x to a power, you add 1, you do the reverse
Okay.
power rule. You add 1 to the power, divide by that number. Again, if it would help you, you could write out some of these. I mean, it's up to you, but if you need to, write out, you know, plug in 0, you'd get 1, you get 1, and then you'd get minus x squared over 1 factorial plus x to the 4th over 2 factorial minus x to the 6th over 3 factorial and so forth. If you need to do that to help you, then write it out, integrate it, and then you're going to have to write a formula in general though. Okay? So if you need to do that, do that.